All right. Thank you. Points, lines, and planes. A point, gentlemen, ladies, aquí por favor. A point has no size. It is so small that it doesn't have a size. It is so infinitesimally small. It's so small that we would never be able to see it. It's smaller than an atom, okay? But if it's that small and we can't see it, it's kind of hard to talk about it. So we use a dot, okay, to represent what it is. But obviously, certainly it is a lot smaller than that dot is. And sometimes that becomes a problem when you're doing compass and straight edge, because your pencil, when it makes a dot, it actually has a size if you were to look really small, okay? And sometimes that's why some of my pictures don't look so great, because I'm putting a very small thing onto something that has thickness. So we only use a single letter, A, B, C, whatever it is. When we did angles, we saw that we needed 3 letters for an angle, okay? A point only needs 1 letter. A line, calibrate this. A lines all last year when you graphed. And you know that a line goes on and on and on in both directions forever, all right? And it goes on in all directions, in both directions. If I have 2 points, I can draw a line through them. And the arrowheads are important because that's telling me that it's not a segment. Okay, and we've talked about line segments before where it stops and starts at a place. But in a full line, they keep going forever. And we write this like this. We have to put the arrowheads on the top of it, because if we don't, then we're saying it's a line segment which stops and starts, okay? In fact, we'll go into that in just a minute, but I want to do a plane first. Okay, when you graphed on a grid in Algebra 1, you knew that that line went on forever, okay? Even though you didn't obviously draw it. And if you zoomed out and looked at that grid would also go on forever in all directions, right? Yeah? Yes, thrilling, exciting. That grid was a plane, okay? It's a flat surface like this ceiling or that wall or this floor, okay? It's not curved, it's flat, okay? Now, this piece of metal is a small piece of what you can think about of a plane. This thing, if it was a real plane, it would go on and on and on forever in all directions, and it wouldn't be this thick. In fact, it would be infinitely thin. And it also goes on and on and on forever. but not just in two directions like a line does. It goes in all directions. And on a plane, if you think about like how a waiter holds a tray, if the tray isn't very heavy, they can hold it up with 3 fingers. You can do it with more, but you need at least 3. If you had 2, it falls. 1 is not going to work because these are all different planes. 2 isn't going to work because these are all different planes if I wobble it. But if I have 3, now I have one and only one plane. So in order to have a plane, you must have 3 points. And since a plane goes on forever, it's kind of hard to draw something that is that big. So we use a parallelogram. That represents my flat surface that goes on forever in all directions. This plane we would say as plane ABC, but sometimes we use just a letter, a single capital letter. Like if I called this Z, if I gave it a name, because it may be a very important plane, a plane that's very important to whatever problem I'm trying to solve. It's so important that it gets its own name. All right. It could be any letter, of course. All right. But here I have my 3 points. Now, if you can see, I don't know if you guys can all see from here, if I make my fingers so that they are all in a row, what's happening? When I put all 3 of my fingers in one row, now all of a sudden, what happened? If I had 3 points in a row, let's see if I can actually do it. See, if I use these 2 fingers, so here I have 3 points, right? Look what happens. It's fine. But the second I get here, why did it fall? It changed, instead of 3 points that were apart from each other like a triangle, it turned into a line. And we have a name for that. When points are all in a line, we call them collinear. These are collinear. And now I can't define my line, my plane. These are non-collinear. If you can make a triangle out of it, then you can make a plane out of it. Same idea behind holding up my tray like a waiter. They're using their 3 fingers to make a triangle. So, if I have 2 planes, thank you. Here are 2 planes, and if 2 planes intersect, when they intersect each other, what does it look like when they intersect? Yeah, a line. And if you think about that, that actually, we see that everywhere. This ceiling is a plane. That wall is a plane. And when the 2 of them intersect, you get a line. Okay? And to draw that, I'll do it by hand. So we have 2 planes that intersected, and they made a line. What happens when you have 2 lines and they intersect? You did in Algebra 1. What happens when 2 lines intersect? What do you get? A point, a dot, right? Not planes, lines. Okay? And you did this 100,000 times last year. Okay. And there. All right. All right. Now, let's, for a second, I have one thing that we can do now. All right. We're going to do this together. Do you pass that over? All right. Let's go through this together. A postulate is something that is very, very simple, that is so simple that we really don't even need to prove it. We can just look at it and believe it. Okay? So, for example, number 1, through any 2 points, there is exactly, what do you think? Give me 2 points, what can you do? There's exactly 1 line. Number 2, who's got number 2? 2 lines intersect, they intersect in, what do you get when you intersect them? 2 lines intersect. A point. Two planes intersect, they intersect in exactly, what is it? We just talked about it. A line. That was the picture we just drew a minute ago. Through any three non-collinear points, there's exactly one plane. Give me 3 points, I'll give you a plane. Okay, now rays, which were the next piece, the way that you write the symbol is very important. All right. This, and this are all different. The top one is a line. That's the whole thing. It goes on and on and on forever. Okay. This is a ray. And just like when you think about a ray, it starts at one place and goes in the direction of somebody else. This would be that. Okay? It starts at C and goes to, it heads in that direction, whatever direction that is. And now CD, what is that? Okay, it stops and starts, has a beginning and an end. And that would just be that one, that piece, okay? So the notation is important. If I were to write this instead, that is not the same ray. This guy, you can switch the order on. This guy, you can switch the order on. The middle one, you can't, because then you're talking about it going in a different direction, and it's not the same thing, okay? So what about 1? What are we going to write? An arrowhead is drawn over the first point or the second point? Second point. You start at the first one and you go through the second point. What about those 3 points for the next one? The 3 points that I picked to make a plane. What do they have to be? Or what can't they be? What was the word that we used about points that were not good when we were writing the when we were drawing a plane? What do we call those guys? Can I just pick any 3 points to make a plane? What makes them bad? Why would 3 points not be okay? If they were all in a line, what do you call it when points are all in a line? Collinear. So, no more than how many? How many do we need? 3 non-collinear points. An arrow indicates what? What is this arrow? I mean, right now you can think about. Oops, sorry. You have an arrowhead here, here, and here. What are those 3 arrowheads telling you? The direction, and that they go on forever in that direction. Which one of these pictures did we use for a plane? Which was the one we liked? A rhombus could work, but some of them didn't always look like a rhombus. Some of them looked like, taking a look at here, like this guy right here. Those guys don't look like squares to me. Which ones do they look like? They look like parallelograms. Okay, that's the one we use. So, and it is, how do we describe, what does it do in all directions? Write it down. Goes on forever in all directions. Or you could scribble out is and just put it does go in all directions. And change it if you need to. Parallelogram. However, the plane actually has no edges. It is, you could say, it goes on in all directions. It goes on forever in all directions. Okay. All right. Now these next two pictures, they really did not come out really well on this picture. You okay? Penelli. Penelli. You all right? You need a drink of water? You look like, yeah, why don't you grab a piece of paper and go get a drink of water? All right. Yeah, so I'm going to redraw these, and unfortunately, you might need to like trace over these little pictures because they're really bad. That's your lunch. See you guys in a minute. We will pause for a commercial break. All right, so we're back. Now, for these two pictures, you might want to like trace over the lines, and because some of the features of these pictures are kind of bad. All right, let's see if we can make this thing look right. Actually, let's do it this way. That's one of them. And let's see if I can make it look a little bit better. That's kind of what this thing looks like, but it's not perfect. All right, and what do I have? I have P, V, S is that one, T, R, Q, W, that's a D, U, and O. And there is a line connect. Let's put it here. All right, and if I'm good about it, I might be able to make it look a little better. Okay, because you don't really see that part. It's actually behind the other plane. All right, and for this cube, literally a cube, I'm going to try and make this look a little bit better. Oh, wrong one. And H, G, F, I. The one that you really can't see is L, and that's the one that's buried in the back, and that really didn't show up on this picture very well at all. All right, now, what we're going to try and solve these problems, and we're going to try and see how some of these planes and things intersect each other, okay? Oops, wrong one, missing a piece. Oh, that's right. No. Okay. Thank you. All right, so PVD and RQU, which are on this guy. Where do these two planes intersect? Because look, they're using three letters, PVD. The point P, the point V, and the... So they're talking about the plane that has those 3 points in it. Talking about this plane. Where does this plane Whoever's thinking about putting food in their mouth might want to change their mind. And where do those two planes intersect? What do you call that? What's it called? Line what? Because remember, it goes on forever. These are full planes, right? But they're just so big, we can't write them in any other way. We have to draw these parallelograms. What do we call the intersection of those two planes? Line, which line? Not a segment, a line. What is it? No. What is the name of the line where these two planes intersect? ST. Don't overthink these guys. Where do planes, okay, now the next one is over here. So we have planes HGF. Is my top and it intersects with IKJ. This one, right. So those two planes intersect and they hit and make what segment do I want? IF or FI. Either one. Make sure you put your arrowheads on it. Whoop. You see, it depends upon whether or not you're dealing with a solid like this, or if you're talking about infinite planes. If we're talking about infinite planes, then they go on forever. Then it would be a full line. But if we're talking about a solid, then it has, you know, a stopping and starting point, and it would be a segment. Okay. So sometimes, and you'll see an example on the homework tonight where they're talking about a shape, and they're talking about a set of planes. Like in this room, these are not real planes that I'm talking about when I talk about the ceiling and the floor and the wall, because they stop and start. They have edges, right? But if we were talking about the Cartesian plane, then it goes on forever in all directions, and it would be a line. So here, yeah, it doesn't say, so we're going to assume that we're dealing with an infinite set of planes. Okay. Next, what about EKJ and GFL? EJK, what is that? Color. Whoops. Oh, something's funny. What happened? What just happened to my... Did I break the computer? Nope, that's right. It fails on you. Especially when it's your technology. Uh-oh. Play nice. This is no good. What have I done? There she is. And she's hanging on me. Okay. Okay. Now that we just had our technology scare for the day, one of these numbers, yeah, E, last one down at the bottom of the first page. Where do planes HGF, let's look at that. HGF, which is the top, This is a great quiz or test question. So HGF, EHG. So that's the wall. And GLJ. And GLJ is the back. So where do all three of them intersect? Point L is not on one of those planes, though. If you think about all three planes, 1, 2, 3, where do all three of them intersect? L is not on the top plane. Just point G? H isn't on the back plane. Just G. Look at my cube. If I talk about three planes, top, side, and side, all three of these intersect at one point. And that one point in this case is G. Okay? Good. All right. Flip to the back. Explain the difference between a ray, a segment, and a line. We're going to jump to the third one. What is the difference between a ray? And you've been answering so many questions. I want to get somebody else. Who else who might have gum, right? Yeah, last 10 minutes of class, busted. Next, you've been answering a lot of questions. I need somebody else. Give me somebody else. You've been answering too many questions too. All right, what do you got? What's the difference between a ray, a segment, and a line? Okay. Segment. Good. What if I wanted you to talk to me about the number of endpoints that they all have? How many endpoints does a ray have? Right. A ray has one endpoint. That's a really bad abbreviation, and I'll fix it. Better. A line, how many endpoints does a line have? Does a line ever end? No, it goes on forever. No endpoints. What about a segment? It has two. It begins and ends. It stops and starts. Two endpoints. Good. All right. What about number 7? Go down to number 7. Got time for these. Take a minute. We got 2 minutes. Talk to your neighbors. Solve the rest of these last questions. You've only got 4, 5 to do. 2, 3, 5, 6, and 7. Talk to your neighbors. And you have your homework assignments. So this episode of The Ronco Show has been brought to you by Points, Lines, and Planes.